Hello guys, welcome everyone to Sabki Kaksha. And today we are gonna talk about the code forces around 957 Division 3. Second question, that is Angry Monk. And the question is read as follows: to celebrate his victory, this person K10ON has baked an enormous 10 meters long casserole. Turns out that the noobish monk just can't stand potatoes, so he decided to ruin the meal and he cut the casserole, n length casserole, into lengths of A1, A2, AK meters such that he cut it into K pieces. But luckily everything can be fixed, so in order to do that, the K10ON can do one of the following operations. Pick a piece with length AI of greater than equal to 2 and divide it into two pieces with lengths 1 and AI minus 1. As a result, the number of pieces will increase by 1. Pick a slice AI and another slice with length AJ equals to I, where the two slices are not same, and merge them into one piece with length AI plus 1. As a result, the number of pieces will decrease by 1. So to find the minimum number of operations, he need to do it in order to merge the casserole into one piece with length n. Okay, so the size of test cases are t is within 10 to the power 4 and n and k are 10 to the power 9, so they are not computable enough. And the sum of k does not exceed 2 into 10 to the power 5. Okay, so let's move to the question. Basically what the question says is the n length array is divided into k segments, and now the segments are of a1, a2, a3 and an such that the sum of ai is equal to n. Now there are two operations which can be performed. Operation 1, we split a piece ai which has length greater than or equal to 2 into ai minus 1 and 1. For example, we have a piece, let's say 213, and we splitted piece 3 into 2, 1, 2 and 1. That is one of length 2 and one of length 1, since 3 minus 1 is 2. The second operation possible is we merge aj and ai to get ai plus 1, where aj is of length 1. Just in the same case before, we can merge the piece 2 and 1 to get a piece of 3. Now what would be the minimum number of moves to get it into a casserole of length n? So now one thing what we can do. Now what are our intuitions? We have two operations, operation 1 and operation 2. Now which one to perform? The first thing. Now after looking at an array, let's take an example array 2, 1, 3 and 4. Let's take the example which was given as itself, that is 2, 3, 1 and 5. Okay, let's take this one 2, 3, 1 and 5. 2, 3, 1 and 5. Now we can perform operation 1 on any of the elements and operation 2 as well on any of the elements. Looking at these operations more carefully, we get one basic intuition, that is operation 1 will split the array and operation 2 will merge the array. But for operation 2 to happen, one of the piece should be of size 1 So given these numbers which are greater than 1, like 2 is greater than 1, 3 is greater than 1, 5 is greater than 1, which one operation should be performed? Operation 1. Operation 1 should be performed first to split them into 1. Then operation 2 can be performed to merge them. Now, do we need to perform operation 1 on all of the tests or on only one? Here comes the second intuition. What do we perform operation 1 on element 2? We will get 1 and 1 in a single operation, and we have if apply it on element 4, we will get 3 1, 2 1 1 and 1 1 1 1. That would be a total of 3 times, that is n minus 1 times, right? Yeah, so it would be better to apply operation 1 on smaller elements. Here comes the third intuition what we get. Now do we need to apply operation 2? Sorry. Do we need to apply operation 1 on bigger elements? The answer is no. Because if we split 4 into 3, 1, 2, 1, 1 and again, then we need to merge all of these again, such that it will again become 2, 1, 1, 3, 1 and 4. So we don't need to apply operation 2 on bigger elements, right? Now since we have applied operation, we don't need to apply operation 2 on bigger elements, what we can do? Let us take this example 2, 3, 1 and 5. Now how to distinguish between the bigger and small elements? The most biggest element only will be merged. Because in the end we only want a single element to stand after the entire operations have been performed. So taking the biggest element as the main pivot on which all the other segments will be merged would be the best option. That is the greedy approach we are talking about. Now, how to perform this set of operation to get the bigger element? One thing would be by sorting, or rather let me write it in different color, that is sorting. 1, 2, 3 and 5. Now we will apply the operations on these n minus 1 element will be applied operation 1. Now since 1 is 1, 2 will be splitted between 1 and 1, 3 will be splitted between 2, 1 and then again 1, 1, 1 and 5 will remain as it is. So total number of operations we applied here is 0, 1 times 2 and 2 times operation 1 again. So the total sum would be 3. Now there is one interesting fact that you can see over here. If we simply do the sum of the n minus 1 elements like this, we will get the same answer again. So indirectly we do not need to compute or simulate the problem statement. We can directly compute it mathematically. We do not simulate. Now what about 5? How many ones we are going to get? We are going to get a total of 6 ones. And how can we like have a mathematical intuition of it? Let's have a look at the above problem statement once again. 1, 2, 3 and 5. Overall, we are having n minus 1 elements that need to be merged with this 5. So 1 will be remain 1, 2 will split into 1 and 1, 3 will split into 1, 1 and 1. Right? Correct. So if we do a sum of the elements, we are going to get the number of operation 2 we need to perform. Now there is one better way to do it as well. We have the count of operation ones, that is C1s we have, right? Here is the value of C1 which we get. Now if we add C1 with n minus 1, that is the number of elements on which we perform the operation 2, we will get C2 directly. Now why will we get this C2? The main reason behind it is, since we are adding here all the elements x after reducing them by 1, so all these 1 when added together will become n minus 1. So directly if you just add C1 with n minus 1, you will get C2. So the total number of moves would be C1 plus C1 plus n minus 1. That would be the simple one-liner answer to this problem statement. Now coming to the time complexity of this problem, since we are traversing the entire loop in order of n, after sorting it, we are going to get the result as order of n log n. Now we will begin with the code, but before that, everyone please like, share and subscribe the channel and hit the bell icon for more notifications. So this is the question which we did just now. Now let us try to code it out and see what we get. Now clicking on angry monk.java. Now first we will import the scanner. The main thing about Codeforces is that we need the test cases in a specific format. So that is the main important thing that you all or everyone needs to take care of. Now looking at the test cases, we have multiple is d, then we have n and k, and the second line contains the k integers. Okay. So for this, what I can do, we can create a class monk, which would store the values that are, you can say, long of n and k. Now the reason why I took long was because the constraints of n and k are given, n is specifically given greater than 10 to the power 9. So that is why I need to take the value of n. Or one way what I can do, I can keep the value of n as long and k as normal integer, and then finally the nums. Then we will create a constructor, a parameterized constructor to input the string, convert the string into an array by splitting it into words on the basis of white spaces. Then this dot n equals to long dot pass long str of 0, and this dot k equals to integer dot pass int str of 1, and the nums would be set with the size of k. Great. Now we need to update the nums as well. Public void update nums, where this string str would be given. Now we can convert it simply into, again, the string s and performing the split operation. Then for each value I up till nums dot length and I plus plus, then converting the string into integer. Then we can create a monk, an array of the class we defined with the size as t for t test cases. Then we will iterate over t, and monks of I will be, we need an object as well. So object equals to new, then using the new keyword for allocation, I will create the ith object. Now for the ith object, I simply need to update the nums, and for that I will again take the input as the next line. Now the values are updated. I will simply run them over for each object in the monks array, and here I will ask out the function println. Let's name the function make monk happy, and over here I'm gonna pass that itself along with k, the length of the array. Because the k defines the length of the array, the number of segments it has been split, so we can pass k as well. We do not need to compute the length. Long make monk happy, integer nums, and integer k. Now here I will define the same parameters as c1 equals to 0. But before that, what we need to do, we need to sort the array nums. Now since we have sorted the array, we need to import more than one object. Now we will start from I equals to 0 and end it at the second last element, and c1 will be incremented by nums of I minus 1. Then we can simply return C1 plus C1 minus, sorry, C1 plus N minus 1 or K minus 1. Here is the object, that is objective being completed. Now we will test it out to see what is the output we are getting. 2, 3, 9 and 15 is the required output. And here is also the same as well. So the code has been successfully completed. Now let us try to submit it. Codeforces around 9:57. Angry Monk. And here we go. It is running. It will most probably be accepted without much issue. It is running on the test case. And you can see here is accepted. So thank you everyone for watching. Please like, share, subscribe to the channel for more videos related to data structures, algorithms on Codeforces, lead code, and every other thing. Also, all the codes which I write, I will be posting them down in the link in the description with the access to my GitHub. You can always have a look over there. Thank you for watching.